Let's look at what we call redox reactions. Why are we talking about redox reactions? You basically have a lot of equations that you'll be writing, and you know the different types of reactions that are taking place. You could have precipitation reactions, you could have what you call neutralization reactions, we have decompositions, and many other reactions. Okay, you can even have those that we term as exothermic reactions and then endothermic reactions. So we have different ways of categorizing reactions. So that means that knowing the different types is actually very, very key. And in this case, we are interested in redox reactions because of three things. And those three things are very paramount in chemistry. The three things relate to electrons, oxygen, and then hydrogen. Okay, these three things are actually very, very important because throughout your study of chemistry, we shall be referring to them a lot. So, for example, if you look at the topic of hydrogen, it will not end there because you have acids, you talk about hydrogen. Okay, you talk about electrolysis, you talk about hydrogen. Okay, you talk about other preparations in the lab or even industrial preparations of some gases, you still talk about hydrogen. So mastering issues to do with hydrogen, oxygen, and electrons is very, very important. Okay, so redox reactions help us to understand these dynamics. For the start, it basically sets the ground for you to know the other topics that will be coming your way in chemistry. But for now, we are interested in knowing what redox reactions are, what they mean. So what are the examples of redox reactions? How can you be able to see an equation and say this equation here is a redox reaction happening in there? Okay, so that is what we are going to look at. Perhaps you could be asking yourself, why are we having such an equation? And it is one of the things that we are going to look at in this presentation. What does an equation like this actually, what does it mean? Okay, because you can see even there is an E with a minus there. What does that mean? So I hope you can pay attention and see where I'll be taking you. So we want to know what oxidation and reduction is, and therefore we need to know what oxidation reduction reactions are, the ones we actually call it redox reactions, and then the examples of reducing and oxidizing agents. So the term oxidation, even the term reduction, can be defined in relation to the three things I mentioned: the electrons, the hydrogen, and the oxygen. Okay, so let's see what each means. In relation to oxygen, oxidation, if you can see that, adding oxygen to a substance is what we call oxidation. When you have copper burning, the brown solid will form a black residue. That black residue is copper oxide. That copper oxide contains copper and oxygen. So you have added this oxygen to that copper for you to form copper oxide, which is a black solid. Okay? Here you had a brown solid turning into a black solid. And that black solid is the copper. oxide. The upper oxide contains copper and oxygen. So it means this reaction here, this reaction is an oxidation reaction because the substance copper has gained oxygen. Then we move to the second way we can define oxidation. In terms of hydrogen, when we remove hydrogen from a substance, we are oxidizing it. So we have hydrogen sulfide there. Hydrogen sulfide is oxidized. This is to say that this hydrogen here is actually removed, and then you will have sulfur remaining alone. And then when we add hydrogen to a substance, it becomes reduced. So the chlorine is reduced to this. Chlorine is reduced to hydrogen sulfide gas. All together. So this equation here, we are having two things happening. That hydrogen sulfide is being oxidized because the hydrogen is being removed. The chlorine is being reduced because hydrogen is being added to it. So the third way we can define oxidation is in terms of electrons. When electrons are lost, then we will have oxidation. Okay, so sodium here is neutral. When it loses electrons here, it becomes positively charged here. So that happens when it is, of course, dissolved in solution. That's why we have that aqueous state, and that is an oxidation reaction. Okay, so reduction is basically the opposite of everything that we have just talked about. Reduction is when you remove oxygen. So hydrogen gas, when it is passed over copper, the copper will lose this oxygen to have this copper alone, and then water will be formed. So you're moving from a black solid to a brown solid. Okay, and the colorless solution will be formed. Okay, so that is reduction in terms of oxygen. What about reduction in terms of hydrogen? Add hydrogen to a substance, it gets reduced. We saw that with chlorine. So here we are saying that when you add this chlorine, this hydrogen to this chlorine, you get hydrogen chloride gas, which is actually greenish yellow. The greenish yellow gas transforming into the white films of hydrogen chloride. Okay, so this green yellow gas is the chlorine here. It's the one that turns to, as a result of this reaction, to white fumes of hydrogen chloride gas. So in this case, we are saying that chlorine is being reduced by to hydrogen chloride by addition of hydrogen. In terms of electrons, reduction happens when there is gain of electrons. Remember, previously, loss of electrons, the electrons are on this side of the equation, but the gain, the electrons are on this side of electrons. Okay, so this also happens where chlorine loses electrons to form chloride ions. So redox reactions are basically a combination of having a reaction where you have oxidation and reduction happening at the same time. And we saw that the previous reaction, where chlorine was actually being reduced, and there was another which was being oxidized. So the redox reactions is just a short form of reduction and oxidation. The red reduction, the ox is oxidation. So that's why we have redox reactions. So in the chemistry lab, you'll be talking about addition of a reducing agent or oxidizing agent. Or basically you get let us say an acid, you add it to a particular reagent in a test tube, and then you'll be seeing reactions happening. So you'll be able to say that this acid that I added either reduced or oxidized. So meaning that the terms oxidation, reducing agents or oxidizing agents, these are things that you need to be familiar with. You need to know the examples of the reducing agents and the oxidizing agents. Basically, what they do, reducing agents, are the things that we have just discussed in reduction. And then oxidation agents, oxidizing agents, are those that we have just discussed in oxidation. Okay, oxidizing agents about addition of oxygen, it's about removal of hydrogen, and also it's about receiving electrons. Okay, so in the redox reactions, using some of these agents, if for example you use an oxidizing agent, the agent will oxidize the substance, but for it gets reduced. This is to say that for it will not remain the same. It will, if it is oxidizing, it will give the hydrogen, the oxygen. An oxidizing agent gives the oxygen, right? So when it gives the oxygen, for it loses the oxygen, and losing the oxygen is reduction. So you give, but you become reduced. Okay? And then the same thing also happens this side. The agent reduces by giving hydrogen, for example, but for it also becomes oxidized. Okay? Whether it is in terms of electrons, whether it is in terms of hydrogen, whether it is in terms of oxygen. That is basically what happens. Okay? So we have lead oxide combining with ammonia gas to form lead. What has happened? The lead oxide has lost the oxygen. So it has been reduced. It has been reduced. And then we come here. We are having the hydrogen here being lost. Losing hydrogen is oxidation. Losing hydrogen is oxidation. Okay, so let's look at what we have here. Is that lead oxide has reduced ammonia, that for it gets oxidized. Okay, for it gets reduced. Why am I confusing it? So in this reaction, editor, note that in this reaction, lead is getting reduced, okay, and then lead is getting reduced, and it is acting as the oxidizing agent. Okay, so like what we said, when you oxidize, that means it is removing hydrogen here. this is lead oxide is oxidizing. So it is, what it is doing by oxidizing is removing hydrogen. And that's why we have this. But for it, it gets reduced. That's what we have just concluded. Is that very clear? So this is, you're having an agent that is oxidizing and an agent that is reducing. Okay? So what is being reduced and what is being oxidized is something that you need to note. Another reaction is here. When you have hydrogen reacting with lead oxide, what will happen? You'll have this. Lead will be reduced. This is a reduction. Lead will be reduced. Okay? Lead will be reduced. And what will happen to hydrogen? It will get oxidized because it gets this oxygen. So that marks the end of this presentation, where we have looked at oxidation and reduction.